Welcome back to the IoT Podcast. I'm your host, Tom White. Every week we are joined by the biggest names in IoT to unravel the trends, misconceptions and predictions for the Internet of Things. Before we get into today's episode, don't forget to subscribe on whichever platform you're watching or listening on and turn on that notification bell so you're never out of the loop. Today's episode I'm joined with Mikko Urho, CEO at Visual Components, a developer of 3D simulation software for manufacturing. In today's episode, we'll be exploring how 3D simulation is being used in industrial IoT and the benefits as well as the emergence of cobots, how they work and how Visual Components are innovating cobots. If you're interested in IIoT, this is a must watch. Before we get into the episode, shout out to our sponsor today, 5V Tech. 5V Tech are specialists in finding people who make technology a force for good in the world. They bridge the gap between talent and deep tech businesses around the globe. Click the link in the description to find out more. Mikko, welcome to the IoT Podcast.
Thank you. Thank you very much for having me today here.
Thank you for coming on to the show. I've been looking forward to this. Mikko, as usual, and there's a way we start this podcast, and every podcast in the world possibly starts when they host a good guest. I wondered if you could take the opportunity to introduce yourself and your journey into becoming the CEO of Visual Components.
Yes, thank you. So my name is Mikko Urho, and I'm a CEO of Visual Components. And I have been working with Visual Components already 20 years. So I came actually in 2003 to make my thesis work at Visual Components. So I have a technical background in production engineering, actually. Then I did some simulation work, modeling work, support work at the beginning of my career here. Then I moved to sales side of it. So we started to sell also software 2005, actually. Since that, I did some direct sales, selling to customers, Visual Components products, first in Finland, then in Europe, and later also globally. And then we started to build also a reseller network. And also after that, when we were growing as a company, I was leading our sales organization. And about 2.5 years ago, I had a chance to step into the CEO position. So it has been quite a journey. I have seen a lot. Company has been changing a lot also during the years. When I joined, I think we were six or seven engineers, and now today we are over 120 employees. So seeing also many countries. So it's been really nice.
Wow. What a fantastic background. You know, it's interesting actually, because on the podcast, and I think, you know, we filmed many. I can't give you an accurate number, although I should know, but we filmed many. I can actually remember on one hand how many people I've met who have grown through the ranks of the business, who have joined either as a trainee or a kind of junior programmer that turned developer. And you've had so many different positions in the business, and it's testament, actually, isn't it, that you have stayed with the business for nearly 20 years, as you've said, and grown up into this position. So you must be incredibly passionate and seen all aspects of Visual Components, both good and bad, over the years.
Yes, exactly. And also the business where we are has been changing a lot. So I think we will talk about it today, but I think where we are today with 3D simulation, I think times are very different than it was 20 years ago.
Yeah.
So there has been a lot of development, and that's why it's been also very interesting to be with Visual Components.
Yes, yeah, I can imagine. So in terms of getting on for an introduction to what Visual Components do, you touched upon it there, 3D simulation. So we've had people on our podcast, and at the time of recording today, it should be released. But we've had people on like Matterport and other people talking about digital twins in simulation, right? And creating replicas. So could you explain what Visual Components do when it comes to primary subject matter expertise?
Yeah, well, Visual Components is a 3D manufacturing simulation software. So that means basically that you can simulate everything what you have in the manufacturing processes. So our customers are using it when you are, for example, creating a new layout to your factory, or you're planning that. Visual Components is used for layout planning, and there you can really see that how this system will work actually. And because it's simulated also, then you can maybe find some errors there that, what might happen if you do it this way. So it's a kind of tool to you to realize that, if there's any problems. And you can also connect it to external controllers like PLCs or robot controllers. So if you want to make a virtual commissioning, so meaning that before you have actual production line in your shop floor, then you can actually do already like a PLC programming for your upcoming system, for example. And then also we acquired a company called Delphi Robotics last year. They are adding robotics offline programming tools to Visual Components. So I will show you later some examples how you can actually create, for example, for arc welding process easily a program. So this is the scope where we are. And when we talk about digital twin, for example, I wouldn't say that Visual Components is a digital twin exactly, but it's a starting point for digital twin. So you need to have a content for digital twin, and then you need to have a communication with the real system, and then also you can benefit from that. But this is our scope. Production system lifecycle from layout planning to actually operating in the software.
Yeah, excellent. I think as you said there, you've touched upon it being a start of digital twins. To go back one step, why is simulation in IIoT so important? Why are there businesses like yours around? What is the advantage to the manufacturing industry in having simulation, Mikko?
Yeah, it's if you think about IIoT, for example, how much data you actually can collect from the systems with that, and 3D simulation is a perfect tool for testing out what will happen if you have the data from your production, and then you want to check out, if I change something in my system, you can actually run that data through simulation and see that, what will be the outcome. So you can predict the future. Many times in IoT environments, you have monitoring system that will actually show the actual status at the moment. But if you want to test something in the future, 3D simulation is for that.
So I think from my understanding and from people that I've spoken to in the past, one of the advantages of being able to test something is ultimately maybe to see where it might break, right? Because it's easier to break something in a simulation than it is to have the cost of doing it in real life. Would you say is one of the big benefits of this?
Yes, exactly. It's a tool to check out if something goes wrong. So predict the future. Then it's always more cost effective to fix it when you realize it with simulation. The same thing when you are building a new layout. So if you realize that, I have a problem with my logic in the system or with the reachability in the robot side, when you realize it on the software, it's always more expensive than if you do the simulation, then you can still fix it on the design table.
Yeah, absolutely. And so who is using Visual Components? Is there any case studies that you can talk about today for any companies who have significantly improved using some of your software?
Yeah, our customer base is we divide it into two groups basically. The ones that are building the production systems, the system creators, machine builders who are actually creating production lines, and they use it for layout purposes when they make a layout proposal to their customer, typically the manufacturing company. So they use it as a kind of sales tool, But it's more than nice pictures. It's also you can provide statistics and also capacity of your new production system, prove the return of investment as well. So it's more than just visualization and nice pictures. The other group, of course, manufacturing companies, they are using it many times when they are planning something new in their factories. So they can actually also have it as internal sales tool, internal communication tool. The group that is designing those things, they can prove their management that, okay, this is why we need to invest on this new production line. Also, of course, if you want to improve things there, so it's typically, or you have many factories all over the world, then you can harmonize your processes in those factories. So that's the way they typically use it. Or if we go to the offline programming side, of course, then typically it might be system integrator who is selling, for example, arc welding solutions. They provide visual component solutions to their customers. Or if you have many robots in your factory, you need to have more easier tools to actually program your robots. Then you can use visual components for that. We have many case studies on our website also, but customer base can be, it's not like industry specific. It can be anything from car manufacturer to shoemaker to really small engineering companies, system integrators in electronics, for example, is many times used. It's not like specific industry, but it's always like a discrete event production.
Yeah, sure. I think, again, it's interesting to see such a wide portfolio of different customers that you work with. One of the things that we've heard about a lot in the podcast and in my own personal experience is this pace of innovation sometimes at manufacturing businesses, and sometimes it can be actually a little bit slower compared to, say, in the home or in other sectors where it can move quite a bit quicker. Do you think that's both a good and a bad thing when it comes to putting your software into these businesses? Is there some reluctance sometimes, but also, perhaps do they see the benefit when they actually see the simulations unfolding when you eventually can work with them? How does that work?
Yeah, it is like, I think we have seen the big change when Industry 4.0 was introduced to the market. So when I started to sell visual components 2005, it was always I have to explain that, okay, what is simulation? Why do you need to do it? But with Industry 4.0, it was brought to companies' attention again. And then we saw in the market that, okay, more and more companies are willing to invest in simulation and to IoT and everything. So I think that there was a clear turn point, but you're right. It's still sometimes some companies are hesitating with new investments to the new technologies. Maybe they have been using some simulation back in 90s and it was difficult and expensive and it still has this reputation. But I think we see more and more trend that companies are really investing on these things like IoT and simulation. So it's and for the companies that haven't done it, I think they have to follow the others. They need to invest on it. So if you want to be competitive in the future, you need to just have these kind of technologies.
Yeah. I think that makes a lot of sense. It's there's an element of, this is a wave of new ways of doing things actually, and when it's in the press and it's widely reported, or perhaps your customers may look at some of their peers in the industry and they're doing something similar, you realize you have to keep up with the pace of innovation, but eventually.
Exactly. It was like that when I started to sell that. Like when I got the first customer, for example, in Finland, I had many other opportunities, but when the first one did the move, it was easier to sell to the others as well. So I still have those old customers. We they are still using visual components, and this was 2006, right, 5, 6 when they were purchasing first licenses. So, but it made it easier when you have a references and they realize, and they were also talking to each other. Okay, what is your experience and so on. So, of course, it helps always with the new technology like this.
Yeah, and I think also from a case study perspective, if in certainly in Finland, it's a fairly small ecosystem of manufacturing businesses compared to other large countries in the world. So being able to reference that, but also having some customers from, as you say, 2005, 2006, you could no doubt they have seen the potential cost savings longer term in running this simulation, which makes it easier for other people to bite the bullet and invest in bringing this in, not only from a monetary cost, but a time cost and a change of practice cost. Because, no matter how you look at it, manufacturing pace is slower. So to make a change, people really need to feel confident that there will be a long-term benefit. Sure. So it makes sense. So getting to the platform in particular then, so how does the platform work?
Maybe it would be good if I can show a video. Maybe easier to explain a little bit how Visual Components platform is working.
That would be great. Yeah. So he says now that for our viewers on YouTube, there should be a video popping up in the next sort of 10 to 15 seconds. So and for anyone listening on Spotify or iTunes or in various other audio formats, you'll have to head over to YouTube to see the video that Mikko is now going to start sharing soon. But it'd be good to see the visual representation of this. Yeah.
So I have the first video just explaining a little bit concept that how the video is actually working or the system works. So you can see the Visual Components user interface here. As also company name is Visual Components, so we are providing library of components, different kind of production devices, robots. I think we have over 3,000 components at the moment available from our library for our customers. So including conveyors, fences, warehouses, AGVs, all kind of equipments that you need in your production systems. And that makes it easy also for our customers to create new layouts. So first we take a conveyor, for example, from our library. Components have a different kind of parameters, so you can easily create your layouts and you can plug and play these components together. So you don't need to be a programmer to be able to do this. So a normal sales engineer can always do this. And then we are also providing over 1,600 different kind of robots from 70 vendors in our library. So you can really test out what is the best robot for your system. And basically you can create the whole factory layout with Visual Components. So here you can see, for example, there's a warehouse system, there's AGVs, there's human workers. Basically you can model your factory in Visual Components. And everything is running in simulation. You can have as outcome nice visualizations, 2D drawings, VR model, or also statistics out of it. So you can analyze the system.
Wow.
So that was a kind of a short introduction that how the Visual Component works in the layout level.
Yes, I mean, it's impressive. You said over 3,000 different components in the library to make up different parts of the warehouse, of the facility. It must take some time to build that, right? If you've got a fairly large warehouse, that must take several days, if not weeks, maybe, to kind of build that out on the platform, including all the different nuances, etc.
Yeah, of course, when you are creating the components of the library, it takes time, and you need to have a knowledge about the logic and how does it work and what is all kind of things you need to know the specific. But the idea of this component-based modeling is that when you have it in the library, you have the parameters, and then you can modify it for your purposes in the layout easily. And you don't need to know how I'm creating the logic for a component like warehouse. then you can just use it from the user interface. So it really makes simulation accessible for the ones that don't know how to program things.
Yeah, sure.
So, for example, or you can really fast create your layout. So that was the original idea of Visual Components, that we extend the kind of user base for 3D manufacturing simulation. It used to be always that, okay, there's one programmer, one engineer somewhere in the corner benefiting from this technology and then providing the results. But now organizations can use it in different levels. You might have those experts in the company, but then you have a lot of users that are using your component library. So you can create also your own components if we don't have something in our library.
Yeah. I can imagine it's such a valuable exercise to do, because once you've built it, then you're just obviously making small amendments to it, aren't you? Right? Because the platform is roughly there, the warehouse is there. So how does it typically work? Just a question on the simulation there. So you've got all of these different components, robotics working together. The warehouse is working, it's on, the factory is doing its thing. How typically can someone see an issue when they're simulating it? What is a common kind of problem that comes up from customers that they have avoided by doing the simulation as opposed to building it without?
Yeah, it's typically when you're creating some new layouts. If you have for example, robot, you can check the reachability with simulation, for example, or make a collision check. So you might collide somewhere in the layout, and in simulation you can check it. That's quite typical. What actually the ones that are creating new robot layouts, they are checking always. Okay, is it collision free, the path, and also that, okay, is reachability okay. The other one is, of course, you might have you might have some problems with the capacity in the system, that based on your original calculations, that, okay, someone is promising, for example, some capacity for the system, and then with simulation you realize that, okay, it's not even close, and you don't know where is it coming from. Then it's good to be simulated always, because you need to think also that how the system works, and then you can make sure that you can actually deliver what you have promised to the customer. So those are the typical cases that.
Yeah, I can imagine that. Yeah, and I can also, just off the top of my head, I can also think of power shortages, etc., making sure you've got the right power coming through. Also, potential heat and ventilation issues as well. I'm sure some of these equipments can throw off a lot of heat. Is there an issue with them working right next to others, or the human element of the factory as well? How close is that person stood next to something that's providing a lot of heat? So I can understand from that simulation point of view, it's absolutely critical actually. And it was good to see the video. Thank you for sharing it.
Yeah. I have another video regarding the offline programming when we talk about the robotic simulation more in detail. And this is what Delphi Robotics is adding to Visual Components. Actually, we are coming up with a new product release now in September. It will be released in second week of September in Schweiz show in Germany, and also in FabTech in the US. And here you can see the functionality. What is the logic, or what is the idea of offline programming? So we can import a CAD model for your product, and here we need to teach the robot to make arc welding process, and we have easy to use tools to actually, by clicking, it will automatically create one arc welding scene. So robot knows how to make this arc welding scene to this location when you're actually clicking that geometry. The other thing is also, we already talked about collision-free path planning. So especially in these cases, you need to have a right configuration for the robot while you are running it, and then make sure that nothing is colliding with the workpiece. So there's automatic tools for that. So we make also offline programming easy. So if we do layout creation easy, we do also offline programming easy. Delphi robotics. And then we have a post-processors to different robots. So you can create your robot program and post-process it to real robots. So that then you can actually start running your real production cell. And here you can see that it's not only for arc welding, but it's also any other, into many of the processes to deeper into painting and so on. So that's the idea of robotics programming, and when it comes to the robotics offline programming.
Yeah, that's fantastic, isn't it? It's so detailed as well. I guess that's what's really staggering about the video is how specific you can be from the simulation. But I would imagine these robotics and the actual equipment is very costly. So you've got to make sure it's in the right area. So thank you for showing that, and good luck on the release in September about that. I'm sure it'll go well, but it's good to get that out there for anyone viewing and listening today on the show. So just to touch on that then, so we didn't cover that earlier, but Visual Components had made an acquisition of Delphi Robotics.
Yes.
And talk to me a little bit about that. What was the acquisition about, and this term cobots, for people that don't know, why did the acquisition come about, and what is cobots in the world of robotics, Mikko?
Yeah. Delphi, we have been partnering with Delphi already over 10 years. So they have been using our platform in their offline programming solutions for some time. And when there was an opportunity, we were thinking that, okay, how do we actually grow Visual Components business in the future? And we always have had very good cooperation with Delphi Robotics before. And we know that they product were the best in the market for offline programming certain processes. So, and we know also the team here, they are also located in Finland, like we are. Visual Components is headquarters in Finland. So they were close by. So it was quite natural that we actually, Delphi Robotics became part of Visual Components. And of course, we wanted to have this tool set in our portfolio and make it accessible for our customers, that they can also, Visual Components customer base can benefit from that. And obviously a new business to Visual Components and to Visual Components partners as well. So that was the main reason. And with Delphi, you can program cobots. Sometimes they need to be also offline programmed. Even if the cobots, you can also teach by hand. So you can just drag them somewhere and make some simple stuff. But when it goes to the more complicated processes, for example, sometimes also cobots, they are used for arc welding or gluing or something like that. Then simulation and offline programming comes to play, because with those tools, you can also program cobots. Likewise, the industrial robots. So those are kind of similar thing in Visual Components. Cobots and robots, you can program and simulate there.
Yeah, well, I can understand why the acquisition, and it's great to know, that you'd worked with a business for so long that it was natural that you would work together. I think that's a really nice success story of a good business working relationship, actually. And for those listening, what is the definition difference between a robot and a cobot? What makes a cobot compared to being a robot?
It's a good question. Actually, I think when cobots came to the market, it wasn't very clear how it's called. But cooperative robot is something that you can. It's a safe. You can teach it by hand, and human worker can actually work with in the same space with robots. And so typically with industrial robots or traditional industrial robots, you need to have safety fences, and they don't stop if they touch something and so on. So there's a clear difference in that. So I think originally I remember over 10 years ago or 50 years ago already we were dealing with first cobot manufacturers, and they said that okay, their first idea was to provide something that you can actually take to your car, take the robot on the table, and then teach the robot in location. And they were saying that okay, they never thought that this needs to be simulated, because the process is so simple that you can actually do it in place and it doesn't take too long. But later stages have been starting to be used in different processes, more complicated processes, and then it comes to more complicated also. So I would say, well, there's certain, in my opinion, both are robots. The other one is cooperative robot, and human worker can work in the same space, and it helps also human worker, of course. If you have some simple repetitive task that you need to do, it's nice to have a cobot, and cobot can do it for you, and then you can concentrate on something more valuable work that helps you to run the manufacturing.
Yeah, so thank you for explaining that. So I was just thinking in my head about that, actually, about what point you'd need a human worker to ensure that piece of work is being done to the correct fashion. That's where you might use a cobot, for instance, right? It might enable you to do it quicker, more efficiently. But the robotic process, that automation of that side perhaps is less critical, or one that has less chance of going wrong, perhaps, right? That's where I can sort of see it. And is that typically how industry use cobots and robots? Is that the separation that you see generally in the market from people that you've worked with?
Yeah, it might be some. I have seen also many funny applications. So I think they have been extending all the time that how actually cobots are used. But I think that's the point that maybe in some applications it's not possible to use industrial robots because of safety. But on the other hand, in some other processes, it's necessary because you maybe need more speed and you need something that you can't have with the cobot. So that's typically maybe the selection.
Yes.
Yeah.
No, that makes a lot of sense. So Mikko, what does the future look like then in regards to 3D simulation and cobots, and what role would visual components play in the advancement of Industry 4.0 and where we might be in 5 or 10 years' time?
Yeah, always we think also that, okay, where we are going, and now what I just explained, that, okay, how visual components is helping customers today. Obviously, more and more layouts are simulated now. I believe in the future, whether you have cobots or robots or any other equipments or automation systems, I think in some point there will be kind of no new systems built before they have been simulated. So it will become as a standard part of the process. Like you have 2D drawing, for example. Typically you create a 2D drawing when you are building a production system. I believe the simulation will be also a standard part in that. Obviously, we see in the cobot side, if we talk about them, it's been huge, the growth, what you see with the cobot market. So more and more applications can be done with the cobots. Whenever you go to the exhibition, for example, in Europe this year, Automatica, some other shows, you always see a bunch of new companies bringing in new cobots to the market. So obviously, that business is growing all the time. And if you think about, we have lack of skilled workers. For example, arc welding. Well, there's not enough welders in many countries. So you need to automate those things. and that means that also more and more robots and cobots will be introduced to the manufacturing side.
Yeah. I can definitely see that happening long term, actually. Now that we have the ability to simulate it, it would not make any sense to not simulate it and take the risk of it going wrong in application. I could completely agree with that, actually. Yeah. So, and I think the use of robotics and cobots in the future is destined to stay, but also become mainstream, perhaps, actually, in all different types of warehouses and industrial sectors, rather than just the ones that we see about in the press sometimes, right? And I'm sure visual components will play a huge part in that moving forward. Mikko, as we come towards the wrap up of the show today, I've got a question from our audience, actually. And I wondered if you might be able to answer it. And the question is, how does Visual Components incorporate cutting edge technology such as VR and AR into your simulation solutions?
It's actually Visual Components has also, we have a product called Visual Components Experience. So already today you can create a VR model from simulation, and you can actually have it in the Visual Components Experience, which is a free software. And then you can have your VR glasses on, and then you can step into the model and see that, okay, how does it actually look like? So it can be a recording, or then you can stream it from simulation. That's an excellent communication tool. So for VR and AR, I think simulation is, again, kind of, you can have a content for that environment easily from simulation. So you don't need to create, for example, make a huge project to build your animation. But when we have customers who are using our tool in layout creation part, and then they also kind of have this VR model for their customers. And the customers can actually go and see that, okay, this is my new production line. So in that, we are not VR company, but we are creating with simulation content for VR environments.
Yes. Yeah, I think that's phenomenal. The fact that you can put on a VR headset and go and walk into the simulation and walk around and touch different parts of it. It certainly brings the simulation to life, as opposed to just being a visualization on a desktop computer, right?
Yeah.
And often we find this convergence of different technologies, really bringing to life, the core components of what that piece of technology might be doing. And I think that's IoT in general, actually. It's a connector, it's an enabler for different things to come together. And it's great to see that. And it's a really good question, actually.
Mm-hmm.
Couple of quick fire questions, Mikko, as we come to the end of the podcast. These are always the interesting ones. We get to know the inside of your mind a little bit better. If you could learn any new skill this year, anything in life at all, what would that skill be, and why would you learn it, Mikko?
Oh wow, what a question! I think. Yeah, very, very good question, actually. I would go for, I think I want to learn more about the cloud environments, strategies there, how they actually will be in the future. So I want to educate myself also in that field.
Excellent. Yeah, I think that's an amazing thing that a lot of people could do with knowing about.
Also, the other one is, of course, AI field. Very interesting, also combined with simulation.
Yes.
It's good. It would be good to have more kind of technical insight. What can be done?
Yes.
I think there's many options what you can actually do with Visual Components environment and combining some AI technologies.
Yes.
It's very interesting.
Yes. Oh, absolutely. Yeah, absolutely. It's a wonderfully exciting world at the moment with everything coming together. And if you could have any conversation with a renowned innovator or inventor, living or past, who would that be and why?
Inventor.
Yes.
What do you mean with the inventor?
So, if there was any inventor in the world or any technologist, someone that you've aspired to or that you've taken influence from over the years in any part of the world, and you could have a conversation with them, who would that be and why?
Obviously, I think the ones that came out with the first car, it would be interesting to know that, okay, what was the process of that? How did they actually come later stage, of course, now electric car, but the concept that, okay, how do you move people from A to B, and what was the thinking process of that?
Yeah.
It would be interesting to know that, okay, how did it actually come up?
Yes. I actually don't know who invented the first car. I know about the Model T Ford, that you could have it in any color as long as it was black, but I think that was some years later, actually. But I can imagine that's interesting. Yeah, the first car. So how did you move on from a horse and cart into a car, right? So it's a big question.
Yes.
Mikko, thank you so much for coming on to the podcast today and telling us about visual components, your journey within the business, the acquisition of Delphi Robotics, and everything that you're doing in simulation. It is fascinating. I can definitely see a world where everyone simulates everything before they actually enact it. And it kind of sounds really logical, actually. It feels like a natural kind of progression. Where can people find out more about visual components online?
It's www.visualcomponents.com. There we have a lot of information. If you want to know more about the Visual Components products, or you want to know about case studies, that's the place to go. Also, our YouTube channel there's a lot of nice videos in that also.
Oh, great. Well, we'll make sure that there's a link in the comments if anyone wants to see any more of the videos that they've seen today on the podcast. But Mikko, thank you for joining us on the IoT podcast today.
Thank you very much for having me. It was a pleasure.
Thanks for tuning in to the IoT podcast. Don't forget to subscribe on whatever platform you're on. See you next week for more IoT talks and tales.